Welcome to Intelligence Gateway.
Network topologies and architecture. Network topologies and architecture refer to the physical and logical layout of a network and its structural design. Topology refers to the arrangement of devices, nodes, and connections within a network, such as bus, star, ring, or mesh topologies. Architecture, on the other hand, encompasses the overall design, protocols, and technologies used in a network, such as client-server architecture or peer-to-peer architecture. In this lesson we'll learn about the application and features of 1. Physical network topologies. 2. Logical network topologies. 3. Network architecture. Physical network topologies. Physical network topologies refer to the physical arrangement and interconnection of devices and cables in a network. There are several different types of network topology, with each having its own features and benefits which make it useful in different situations. In a star topology, devices in a network are connected to a central hub or switch. The central hub serves as a central point of connection and facilitates communication between devices. Each device has its own dedicated connection to the hub, creating a star-like arrangement. In this topology, if one device or cable fails, only that specific connection is affected, while the rest of the network remains functional. This makes troubleshooting and maintenance easier, as the failure of one device or connection does not disrupt the entire network. Star. In a star topology, devices in a network are connected to a central hub or switch. The central hub serves as a central point of connection and facilitates communication between devices. Each device has its own dedicated connection to the hub, creating a star-like arrangement. In this topology, if one device or cable fails, only that specific connection is affected, while the rest of the network remains functional. This makes troubleshooting and maintenance easier, as the failure of one device or connection does not disrupt the entire network. Extended star. An extended star topology is an extension of the traditional star topology that includes additional layers or levels of hubs or switches. In an extended star, multiple local star topologies are connected to a central hub or switch, creating a hierarchical structure. The central hub or switch in the extended star serves as a connection point for the various local star networks. Hierarchical. Also known as tree topology, is a network architecture that resembles a hierarchical structure similar to a tree, with a central root node branching out to multiple levels of child nodes. It is widely used in computer networks to connect devices, such as computers, servers, switches, and routers. In this topology, each child node can have multiple child nodes of its own, creating a branching structure. The root node acts as a central point of control and communication, while the child nodes are connected to each other in the root node. This architecture allows for efficient data transmission, as information flows in a specific path from the root node to the desired child nodes. Wireless mesh. Wireless mesh refers to a network infrastructure where multiple wireless devices, such as access points or nodes, are interconnected to form a mesh-like architecture. Unlike traditional wireless networks that rely on a central access point, wireless mesh networks create a decentralized and self-configuring network. Each device in the network acts as a node that can transmit data and also relay data for other nodes, thereby extending the coverage and improving network performance. Ad hoc. Ad hoc refers to a type of wireless network configuration where devices communicate directly with each other without the need for a central infrastructure or access point. In an ad hoc network, each device acts as a node and can transmit data directly to other nearby devices within range. This decentralized approach enables devices to form temporary networks on the go, allowing for spontaneous and self-organizing communication. Ad hoc networks are commonly used in scenarios where quick deployment and flexible connectivity are required, such as in emergency situations, military operations, or temporary gatherings. These networks rely on the devices themselves to handle network management functions, including routing, addressing, and security. Logical network topologies. Logical network topologies refer to the conceptual arrangement and interconnection of devices in a network, focusing on the logical relationships and data flow between devices. They describe how devices communicate and exchange data without taking into account the physical layout or actual connections. Logical network topologies are typically represented through diagrams that illustrate the logical relationships between devices and the paths through which data travels. They help in understanding and designing network architectures, addressing issues like data transmission, network efficiency, fault tolerance, and scalability. Network architecture. Network architecture refers to the design and structure of a computer network, including the arrangement of its components, protocols, and technologies. It encompasses the overall framework that governs how devices, systems, and applications communicate and interact within the network. Network architecture involves decisions regarding the physical layout, logical organization, and connectivity options, as well as considerations for scalability, performance, security, and manageability. A well-designed network architecture ensures efficient data transmission, effective resource utilization, and seamless connectivity across devices and locations. It provides the foundation for reliable and robust network operations, supporting various services and applications while accommodating current and future business needs. Peer-to-peer. Peer-to-peer, P2P, refers to a decentralized network architecture where participants in the network act as both clients and servers, sharing resources and communicating directly with each other without relying on a central server or authority. In a P2P network, each device or node can initiate and respond to requests, making the network more distributed and self-organizing. Participants can share files, information, or services directly with one another, enabling efficient resource utilization and fostering collaboration. P2P networks are commonly used for file sharing, content distribution, and communication applications. Client-server. Client-server architecture is a network model where clients and servers interact to provide services and share resources. In this model, clients, which can be computers, mobile devices, or software applications, request services or data from servers. Servers, on the other hand, are dedicated machines or processes that store data or provide specific services to clients. The clients initiate requests, and the servers respond by processing the requests and sending back the requested data or services. Thin client. A thin client is a computing device or software application that relies on a central server to perform most of its processing and storage tasks. In this architecture, the thin client acts as a lightweight terminal that connects to the server over a network, typically using a remote desktop protocol or a web-based interface. The server handles the majority of the computing workload, executing applications, processing data, and storing information, while the thin client simply displays the output and sends user input back to the server.
Thanks for watching. For more information, like, comment, and subscribe our channel.